when we talked about the definition of a circle, we told you that there was a center point, and we told you that there was kind of like this r sub x and a r sub y. And we told you that r sub x equals r sub y. The next evolution is, what if they're not the same? What if r sub x is greater than r sub y? And the first thing is, it's not a circle, right? It makes an oval. And the mathematical term for an oval is an ellipse. So what would this look like? Watch this. Check that out. So what we have here is an ellipse or an oval, and we still have a center point. And so what I could do is I'm going to grab this and let's label some things. We took that center point when they were equal, right, in the circle, and that center point kind of got split in two. There is still a center point, and it has coordinates h, comma, k. You also have an r sub x, which goes this way. This is the radius in the x direction. And you also have a r sub y that goes this way. When r sub x is greater than r sub y, you have an ellipse that looks like this. Because the radius is greater in the x direction, it's stretched in the x direction. If, on the other hand, r sub x is less than r sub y, then you have an ellipse that looks like this. It's stretched in the y direction. So when your ellipse is stretched horizontally, the major axis is called r sub x, and the minor axis would be r sub y. Because r sub x is bigger, right? We call the larger radius the major radius, or the major axis, and the smaller radius is called the minor, major minor. Pretty simple. On the other hand, if your ellipse is stretched vertically, then r sub y is the major axis, and r sub x is the minor axis. The points where these hit the edge here, these are called vertices, or a vertex. We'll call it a vertex. Kind of like the vertex in a parabola. So you have a vertex there, and you have a vertex there. There's one other key feature that an ellipse has that a circle does not have. The focal point is A. This is a focal point. And this is a focal point. So when we took that center point and we split it in two and stretched it, that center point actually became two focal points, mirrored focal points, the same distance away from the center. So now we have a center point, we have vertices, and we also have a focal point. The center point we know. This is h and k. That's pretty easy. The vertices, could we figure out what the vertices are? Sure. You're going to take h and k, and you're going to either add or subtract r sub x and r sub y. The focal point, though, is not so easy to calculate, and you actually have to do a little Pythagorean theorem on it. You end up with this. The focal point is equal to the square root of r sub x squared plus r sub y squared. That's the focal point. And it comes from the Pythagorean theorem. Let's talk about coming up with the equation for an ellipse. So think about the circle. We had x minus h squared plus y minus k squared equals r squared. And for a circle, we assume that the radius was the same. We're going to divide everything by r squared. And now what we get is something that looks like this. And the radius that is underneath the x term, the x minus h, this is r sub x. And the radius that's under the y term is r sub y. And this is the equation of an ellipse. Here's your standard equation of an ellipse. And let's find out some things. Where is the center? What is r sub x? What is r sub y? Center is located where? 3, 6. R sub x, and that's going to be 5, right? Square root of 25 is 5. And for r sub y, you're looking at the radius under the y term, You'd square root that, and you'd get a 4. So could we sketch this? We have a center point at 3, 6. My radius in the x direction is 5 units. So starting at my center point, I go 5 units. I also go 5 units the other way. My radius in the y direction is 4. And that creates 4 points, 4 vertices. Let's label the coordinates of these 4 vertices. And this is where you just have to do a little bit of simple math. So when you look at, let's start with this one right here, the x. So let's label this one. So this is a vertice, a vertex. What are its coordinates? It's 5 units in the x direction. So you added 5 to the x coordinate, which was a 3 to begin with. So it's 8, 6. Let's go the other way. What's this vertex? The vertex going to the left, negative 2, 6. Let's go up. So starting at 3, 6, what are the coordinates of the vertex above the center point? 3, 10, because you added 4 to the y coordinate. And now you're going to subtract 4 from the y coordinate, and you're going to get 3, 2. Which axis is the major axis? And we'll color this in yellow. Yeah, x is the major axis. Yeah, because it's the larger number, right? It's 5 is bigger than 4. So the radius is bigger in the x direction. What's the minor axis? The y-axis. And we could connect this with a line or dots or something and make it look like an ellipse. So I guess we should answer some questions. What's the center point? We know that, 3, 6. List the 2 major vertices. Now they say major vertices. So what does that mean? The vertices on the major axis, right? So I think that's going to be negative 2, 6, comma 8, 6. Yeah, how can we make this more difficult? How about we don't give you standard format? So I rearrange, I group the x's together, I group the y's together, and now we're going to complete the square. So I'm going to factor a 36 out. And then we're going to factor a 16 out of the y terms. What goes in the blank for the x term? 2 divided by 2 is 1. Squared it, gives you a 1. But we're not just adding 1 to that side. What are we really adding? 36, right? So that means we got to add 36 to this side. And now you do the same thing for the y's. So take the middle term, divide it by 2, and square it. 9. But we're not really adding 9. We're adding 9 times 16, which is 144. All right, so now this becomes 36 times, a perfect square. X plus 1 squared. Plus 16 times, perfect square. Y plus 3 squared equals 576. Divide everything by 576. There's a couple of very nice things that happened here. Number one nice thing. This number times this number is this number. So now when you divide, you know that this 16 actually is going to be that number, and this 36 is going to be that number. The other nice thing is that 16 and 36 are both perfect squares. Where is the center? Negative 1, negative 3. What is r sub x? And what is r sub y? So could we draw this? Yeah, I guess we could try. Let's circle this up, put it over there. So here's an x and here's a y. Our center is at negative 1, negative 3. So negative 1, negative 3 right here. That's our center point. Our radius in the x direction is 4 units. So 1, 2, 3, 4. 1, 2, 3, 4. Radius in the y direction is 6. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So it's going to be something like this. Major axis is the y radius. Y-axis is the major. Minor would be the x.